We're going to review how to find a fraction of a whole number and the process of cancellation. Let's find the value of 3/8 times 20. We're going to take a look at three different methods, starting with the way that we knew how to solve this problem already and ending with the way that we're going to be solving this problem moving forward. So in method 1, we're going to rewrite the problem 3/8 times 20. We already know that we're going to multiply the numerators together. So we're going to multiply 3 times 20. And our denominator stays the same. Our denominator will be 8. Then we're going to multiply 3 times 20 and get 60 over 8, 60/8. We know that since both of these are even numbers, we can simplify it by dividing by 2. I also know that they're both divisible by 4. And so since 4 is the greatest common factor that I know, I'm going to divide both my numerator and denominator by 4. 60 divided by 4 equals 15. 8 divided by 4 equals 2. So now I have 15 halves, which I can turn into a mixed number of 7.5. 2 goes into 15 7 times. I'm left with 1 part, and it's 1 out of 2, so 7.5. Now let's take a look at method 2. In method 2, I'm going to start the same, rewriting the problem 3/8 times 20. I know, again, that I'm going to multiply my numerators, just like we did in the previous problem and like we've learned to do in the past. So I'm going to rewrite 3 times 20, and 8 will be in my denominator. But now I'm going to take a look at these numbers, and I'm going to see if I can find a common factor in my numerator and denominator. Looking at this problem, I know that 20 can be divided by 4. 8 also can be divided by 4. So I can actually cancel these two numbers out, cross out my 20, cross out my 8, and divide them both by 4 now, instead of multiplying and dividing them by 4 later like I did in method 1. It makes the math a little bit easier because we're dealing with simpler numbers. So 20 divided by 4 is 5. 8 divided by 4 is 2. Now I'm going to multiply again 3 times 5 over 2, and I get 15 halves, which again, when I turn that into a mixed number, becomes 7.5, and that's boxed because that's our final answer. So you can see that the difference between method 2 and method 1 is that I can now simplify earlier in the problem. Let's take a look now at method 3, which is the way that we're going to be practicing our problems from here on out. We're going to rewrite the problem as we did previously, 3/8 times 20. I'm going to now cancel my 20 and my 8 during this first step. So this is called cancellation. 20 can be divided by 4, as we saw previously, and 8 can be divided by 4. What we've done, what you see from method 1 to method 2 to method 3, is that we can complete this step, this simplification, earlier in the problem. So I'm looking at my numerator of 20 and my denominator of 8, and I'm asking myself, do they have a common factor? They do. The common factor is 4. So I will divide by 4. Now again, I'm going to multiply 3 times 5, and 2 will now be in my denominator. So I've just made the problem simpler by canceling sooner in the problem. Now I will multiply and get 15 halves, which again is equal to 7.5, and I'll box that because that is my final answer. So when you cancel in the original problem that is written, this is called cancellation. And this is the method that we're going to be practicing from here on out. You want to always look for the greatest common factor and cancel with that number. But if you don't have the greatest common factor, that's okay. You'll just end up canceling maybe twice or maybe 3 times, and that is perfectly fine. Okay, let's give method 3 a try. I'm going to go through a few problems so that you can see how method 3 is executed when solving. First, let's take a look at 2/5 times 10. I'll rewrite the problem, and then I'm going to cancel out my 5 and my 10 because I notice that they can both be divided by 5. So I'm looking at my numerator, which is 10, because we know that that's a numerator because in a whole number, our denominator is always 1. So we look at that numerator, and then we look at our denominator, and we ask ourselves, do they have a common factor? Here it is 5. So 10 divided by 5 equals 2. 5 divided by 5 is 1. We then multiply our numerator and denominator, and we get 4 over 1, which is the same as 4 whole. Now let's take a look at 5/6 times 8. Again, I'm going to look at my numerator, which is my whole number, and my denominator, and I'm going to see if there's any common factors. There is a common factor here, which is 2. So I can cancel them out, and 8 divided by 2 is 4. 6 divided by 2 is 3. Now I'm going to multiply and get 20 thirds, which can be turned into a mixed number of 6 and 2/3. All right, let's take a look at one last example. 3/4 times 18. Again, I'm going to look at my numerators and denominator and see if there's any common factor. 18 and 4 do have a common factor. They both can be divided by 2. So we're going to divide by 2 and write the other factor in its place. 18 divided by 2 is 9. 4 divided by 2 is 2. We then multiply and get 27 halves, and we then turn that into a mixed number, which is 13 and a half.